Application of linear equation in one variable. Given, Eric is 35 years older than his son Bryce. 2 years from now, Eric's age will be 6 times as Bryce's age. How old are they now? In our first sentence, Eric is 35 years older than his son Bryce. Therefore, Eric's age is dependent to Bryce's age. So we will start representing on Bryce's age. So let x be Bryce's age. Then Eric's age is x plus 35. Why? Because Eric is 35 years older. So it means that is Bryce's age plus 35. So after representing their ages, we will use a table to organize our data. So it is advisable in dealing with an age problem. It is good to use a table to organize our given data. So we know that Bryce's age now is represented by x since we do not know it yet. Eric's age is x plus 35 because he is 35 years older than his son. Now, in our second sentence, 2 years from now, so we have another element here or time element. That is 2 years from now. So if we are now on 2022, so let's say we are now on 2022, so we are referring to 2024. Okay? So in 2 years or in 2024, how do we represent Bryce's age? So that is simply x plus 2. We just add 2 years on his current age. Then Eric's age, which is x plus 35, it becomes x plus 35 added by 2. Or 35 plus 2, that is 37. So after writing our data using this table, we are now on the process of setting up our working equation. So using this second sentence, 2 years from now, so it means we will only be focusing on this column right here. So 2 years from now, Eric's age, so since Eric's age is represented by x plus 37, so x plus 37 will be, so it is translated as equals 6, then times Bryce's age, and Bryce's age in 2 years is x plus 2. And if we're going to write them together, this will be our working equation. Okay, so x plus 7, that's Eric's age, will be, that's the equals, 6 times Bryce's age. So let us now simplify this working equation. So 6 times x, 6x, 6 times positive 2, that is positive 12. Then write down x plus 37. So we have x in each side of the equation. We're going to eliminate one of it. So I prefer to eliminate the smaller one, the 1x. So that is by subtracting x in each side of the equation, applying the subtraction property of equality, because we want to eliminate this. And write down 37 on the left side, then 6x plus or minus 1x becomes 5x, then write down plus 12. We can now focus on this x right here. We're going to isolate this by eliminating plus 12 and times 5. Let's start. So applying the subtraction property of equality again. Subtract 12 to both sides because we want to eliminate this. And 5x is left on the right side. Then 37 minus 12, we have 25 on the left side. Finally, applying the division property of equality, divide 5 in each side of the equation. So that 5 divided by 5 is 1. Then 1 times x is x. Then on the left side, 25 divided by 5 is 5. So this x equals 5. And that x represents Bryce's age. Therefore, the age of Bryce now is 5 years old. Now, to find Eric's age, so since Eric's age is represented by x plus 35, so in this expression, we know that x is 5, so we'll just simply replace x by 5, then 5 plus 35 is 40. So this 40 right here is the age of Eric now. So to check if these answers are really correct, so going back to our given, Eric is 35 years older than his son. Is it true that Eric's age, which is 40, is 35 years older than his son, which is 5 years old? Yes, it is. Because 40 is 35 more than 5. Now, in 2 years, Eric's age becomes 6 times the age of his son. So, That is in 2 years. So it means we will add 2 to their current year. So 5 plus 2, it becomes 7. This will be the age of Bryce in 2 years. Then Eric's age becomes 42 in 2 years. Okay, so let's see. Is it true that Eric's age is 6 times? Yes, because 6 times 7, that is 42. So since it satisfies our first and second sentences, therefore, these are the answer of our given problem number 1. In given problem number 2, a 30-year-old mother has a 4-year-old daughter. In how many years will the mother's age be thrice as old as her daughter's age? So, although it is also an age problem, but in this case, we are looking for a certain year. In how many years wherein mother's age becomes three times the age of her daughter. So we're going to represent this certain year by x. Then we will prepare a table. So since in this given, we know for a fact that mother's age now is 30, it is given. Daughter's age is also known, which is 4. Then to represent their age in a certain year, we do not know yet. That is why we use x. So to represent mother's age in a certain year, so that is x plus 30, or it can be 30 plus x. Then daughter's age in a certain year, that is x plus 4. So after completing our data, we are now in the process of writing our working equation. So using the second sentence, in how many years? So we are on this time element on a certain year that we do not know. Mother's age, so mother's age is represented with x plus 3. So that x plus 30. Then will be, so this be or will be, that is equals, then thrice represented by 3. Then daughter's age, that is represented by x plus 4. And we're going to write these terms, that will be our working equation. So x plus 30 is the mother's age, will be 3 times daughter's age, which is x plus 4. So same process like what we did in our first example. So 3 times x, 3x, 3 times positive 4, that's positive 12. Then write down x plus 30. Then we will eliminate this x right here, applying subtraction property of equality, so that x minus x is 0, and we are left with 30. 3x minus 1x, that is 2x, write down plus 12. Then we want to isolate this x, that is by applying again subtraction property of equality, so minus 12 to each side of the equation. So on the right side, 12 is eliminated, we are left with 2x. Then on the left side, 30 minus 12 is 18. Then finally, applying the division property of equality, divide each side of the equation by 2, so that 2 divided by 2, we are left here with x. Then on the left side, 18 divided by 2 is 9. Therefore, this x equals 9. And that x represents the certain year wherein mother's age becomes triple compared to her daughter's age. So let's check if our answer is really correct. So since we know that this x is equal to 9, so we can replace this x by 9. So the age of mother in 9 years, so that is 9 plus 30, which is 39. Then daughter's age in 9 years, so that is 9 plus 4, so that is 13. So is it true that mother's age is triple compared to her daughter's age? Yes, because 13 times 3, that is the age of the mother. So it satisfies our given problem. Therefore, this is the answer of our question.